Hello, and welcome back in our class today. My name is Victor Odigoma here, and in our class today, we are going to be looking at a question that has to do with the properties of chords. Okay, we have done a lot of classes already. We started looking at the circle and its properties, and we have been able to look at questions that has to do with segments, question that has to do with sectors, question that has to do with the issues around segments, like calculating the radius, the angle at the center. And when you have, in fact, there are several classes we have done already. The essence of that is that if you have not known, if this is your first time of being here, you need to check out on those classes so that you can be able to follow us in what we are doing at the moment, because right now we are going into chord properties like I promised us, and then from chord properties we're now going to advance into circle theorems as the case may be. So in chord properties, still within the circle geometry, okay, you understand that we have some things we know about the chord. One of them is the chord theorem that says any line drawn from the center of the circle, which is perpendicular to a chord, that line will bisect that chord and is also at right angle to that chord. So that theorem, we are going to make use of it. That theorem is a chord theorem, okay, that says any line drawn from the center of the circle perpendicular to a chord, that line bisects the chord. What does that mean? It divides that chord into two equal parts, and it is at right angle to that chord. We are not going to be proving that theorem now. Yes, the proof is there, but we are going to deploy it. We are going to make use of it in answering this question you are seeing here. All right, let's quickly delve into it. This question says two parallel chords of length 10 cm. Like these are two parallel chords. They have the length 10 cm and 24 cm are on the opposite sides of a circle of radius 13 cm. You say find their distance apart. Find their distance apart. So how are you going to answer this question? You know that the first thing you do is you put up a diagram. You put up a diagram that will explain or that will show you a clear picture of what this information is all about, so that from that diagram you can be able to proceed into the calculations that is required of you. So in doing that, you have to draw a circle and then position the chords. Okay, let me shift it somewhere here. This thing shifted a little bit. Okay, let me tidy it up. So this is our circle with center somewhere here, to the center somewhere there. Now we are told that two parallel chords. There's something I need us to understand. That thing is that the closer a chord is to this center, the wider it is. I don't know if you understand that. And the further away it is from this center, the shorter it is. So that's the concept I'm going to use now in positioning these two chords. So the one that is 10 cm should be further away. The one that is 24 cm should be closer. You get that? Okay. So Okay, so and this one closer to the center. Okay, I'm sure you saw that. Okay, then you see that this is closer. All right, now like in the theorem I just explained now, that I said that any line drawn from the center of this circle perpendicular to a chord bisects that chord. It's a chord theorem. So I am going to mark something here. Okay, all right. Now we were also made to understand, get it, if I do this, that here will be 12 cm. I think the unit is cm, 12 cm, making this chord, let's say AB, the chord AB 24 cm, and this chord CD, CD 5 cm here, 5 cm here. Okay, because of that bisection. So this will be reduced from this center. The radius is said to be 13 cm. Okay, 13 cm. Now I'm sure you 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 saw that how I was able to connect this circumference to the center. That's what makes a radius, right? So uh, also do the same thing here. Some of my students, they will ask me, is it a must you must position it this way? What if you do it this way? Yes, that shows that they are making use of their brain. Yes, because this same thing I did this way, you can still do it this way, and you're still correct. Okay, all right. I think we can make some instructions here. I am trusting God that this diagram clearly, you can see with me that this diagram clearly captures what is said in this information, what is given in this information. So you can see the chord, and this chord, my labeling, let here be center O, let here be N, and let here be M. So I have to give those you know labels so that you can be able to extract some things. You can be able to extract some things. Now, there are two things I want to extract from this place. Now, I want to remove this triangle and also remove this triangle, because let me call here MO. MO. From here to here, let me call it X. I can define it. I can say let MO equals X, and let NO equals to Y. So here is Y. So that will help me in the calculations we are going to be doing inside there. Okay, that will help us. So let's do a little extraction. Uh, let's do a little extraction. Okay, okay. Like this is too big. Let me make it shorter. Okay, okay. So this is my M, and this is right angle. Okay, according to that theorem I explained to us. Okay. So here is D, and here is O. This is 13 cm. This is 5 cm. Okay. Now, do you realize that here being X, that I can say solving for X using Pythagoras theorem, that says that opposite squared plus adjacent squared, that is MB squared is equals to the hypotenuse squared. The hypotenuse is do squared. Okay, so we have here as x squared plus 5 squared equals to 15, no, not 15, 13, equals to 18 squared. So this is x squared plus 25 equals to 169. Okay, so we have x squared equals to 169 minus 25. 169 minus 25, we have x squared equals to 169 minus 25. 5 out of 9 will give me 4. 2 out of 6 will give me 4 again. And then I'll bring down 1. So that's 144. Okay. So I think comma x here is equals to square root of 144. And x will be equals to 12 cm. Square root of 144 is 12 cm. Okay. I will keep that. I'm sure that you followed me in what I gave here as an explanation. I'm sure you followed me. All right. Now we can also make another extraction of this. You can also make another extraction of that. So we have something down here this way, okay, this way, then okay, then we join it, okay, okay. This is N, this is B, and this is O. This is 13 cm, this is 12 cm, and this is Y. Okay. So we can still say again, calculating the value of Y using Pythagoras. Pythagoras theorem. So it says y squared, that is opposite squared, plus adjacent squared, which is NB squared, equals to hypotenuse squared, which is BO squared. So have y squared plus NB, which is 12 squared, is equals to 13 squared. Y squared is equals to, this goes over here and be 169 minus 144. So y squared is equals to, because this difference will be 1 out. We have 2 here and we have 5 here. Okay, so that's 25. So we have y equals to square root of 25. So we have y equals to 5 cm. We can now begin to make our conclusion. Okay, about the distance. Remember they say what the distance apart about between these two parallel chords. So we can start making our conclusion. Our conclusion here is that therefore we can now say therefore mn which is equals to x plus y will be equals to 12 plus 5, and that will give us 17 cm. So this is the distance between these two parallel chords. Okay, that's the distance between these two parallel chords. I am trusting God that my explanation is very, very clear and simple. Okay, very, very simple. So please, I am trusting God that you like what we are doing. Yes, I definitely believe so. And if you like what we are doing, yeah, I am imploring you to share it to someone else out there, and then click on the subscription. You know, we have a lot of classes we've done already, over hundreds of classes, and across various mathematical topics. Please, if you click on the subscription button, you have access to those classes at once, and then you can also share it to your friends out there so that they can learn as well. Okay, and then also you partner with us so that we can, you know, be able to make more impact. Please like our video and share it to someone else. And as you do that, God will bless you. Thank you so much for being there.